I'm sort of following up on some earlier presentations. We've been looking at some packages that are like alternatives to dplyr for doing data manipulation type stuff in R. So stuff like we've touched on like data.table, dtplyr, and variations of DuckDB like duckplyr and just the DuckDB package itself. So today I'm going to go through some like public benchmarks of some of those packages, as well as I did my own benchmark. So we can take a look at basically both of those and see sort of like how things rank in terms of performance. Most of the benchmarks really focused on speed, although I guess another variable to keep in mind is memory, because a lot of packages that are like data.table, for example, is often more memory efficient than dplyr. So yeah, we can all sort of just, I found a few benchmarks on here. I guess we can just go through 3 of them. So I guess before I really go into these, I will mention that I was messing around with like duckplyr mostly. So this was I was sort of searching benchmarks related to duckplyr. That might have biased my search results a little bit. So all of these benchmarks include either DuckDB or duckplyr. And so depending on the use case, you might get different performance results from different packages. So these might be sort of biased in favor of DuckDB and duckplyr. But so this benchmark, he mentions like the packages that he's going to be comparing. So dplyr is sort of the ground, what's it called? Not the ground truth, but sort of like the back reference for the comparison, as well as duckplyr, data.table, and then also these packages that we haven't really gone through on our stats club sessions yet. So polars, there's also a tidy variant, tidy polars, and then collapse. And then these are all sort of like I mentioned, sort of these are like performance packages developed with like performance in mind. Like polars is based on Rust, which is quite fast. Collapse is based in C++, which is obviously a lot faster than R as well. So yeah, those are the packages. I'm not going to go through too much of through the whole thing, but like basically like the data set, I guess I'll start with the data set. So he uses like a football related data set here. So this was like, he says it's like about 1 million games. So I believe that's like 1 million rows. Actually, let's see, 1.2 million rows. And so, yeah, he does a lot of setup to like work with all the packages. And then he uses like this micro benchmark package where he repeats the benchmark 100 times. And then basically this is like super simple. He's not doing anything complicated in terms of like the tasks to benchmark. It's just doing like a group by and a summarize essentially across, like calculate the average number of goals scored at home for each team. So yeah, a group by, and so the syntax might look a little different for each package, but that's the entire setup. And so I guess I'll just get right to the results here since it's pretty quick. So interestingly enough, DuckDB was like the best performer here. And then yeah, you can see like data.table is also quite good. Although no, this is like a log scale for the time for the x-axis. And then dplyr is the worst, sort of like that's expected as like these packages are developed for performance in mind. So this is how this benchmark sort of plays out. So yeah, these are really short tasks, and they're really just doing a group by and summarize. So in general, like as I was looking through some of these packages, like it seems like DuckDB is really good at like grouped operations, or really fast with grouped operations. So I'll go through 2 more. I mean, the results are pretty similar, although some of the use cases are a little bit different. This one was using a data set with 1 billion rows, so slightly bigger, actually like 10 times bigger, I think. So it started with like a text file, although as I was looking through the code, it looks like he just reads it in like a normal CSV or something. I don't know why he, sorry, let me displayed it like this. But this one's a little bit more complicated. It involves a lot more processing. So I think I'll get to this one's a little bit more complicated because he does like a bunch of different options. So he does some stuff in base R. So a lot of processing here. There's going to be like taking, actually, I wasn't sure when I was looking through, because I think going down, if we sort of skip this section, yeah, I think we'll start with like this because there were like less complicated implementations in base R that would be probably more natural to use, like read.delim for this text file. And then we can sort of focus on the operations that he's doing here. So again, there's a lot of like summarization by taking the min, mean, and max values across different columns here, and as well as some sort of like string parsing here. So it's somewhat similar in that I mean, it's a little bit more complicated than the previous example, but a lot of like summary statistics across a large, ultimately like a CSV type file. So I didn't look through this too much in advance. So we can get to sort of like the dplyr variations. So like I said, it's like there's some summary statistics and then some manual parsing of like some of the strings. So yeah, that's the dplyr variation, and many other packages are being tested here. So data table and sort of the native data table syntax, which is somewhat similar but a little different, doing the same sort of thing. Similarly, DuckDB is benchmarked here. In this case, he shows doing it with like the first like similar to the way I did it in the first RStat session I did DuckDB, which was translating it into SQL. Although he mentions at the end, like this is not necessary because you can use duckplyr, which uses just the dplyr verbs and sort of overwrites them. So those are the packages. I know I skipped a couple of them. Here are the results. So a bunch of the first ones are using like base R variations. So like he shows like basically the most basic base R version is extremely slow. Tries to parallelize it with the parallel, and I think for each packages. Aggregate, I'm not sure what's going on here actually, because that I'm not quite sure about. But I guess the other options on the right are dplyr actually is quite a bit, interestingly enough, is quite a bit faster than base R. So I didn't really know that it was expected to be faster than base R when I was going through these. Data table does really well, but then DuckDB is again sort of the best by this benchmark. So DuckDB has been doing pretty well in these benchmarks, but like I said, I've sort of biased my search results towards DuckDB. But so we'll do like one more benchmark. I don't want to get like too redundant with this, but this one, just trying to, we'll go through this. So basically this one involves simulated data, generating 100 million rows. So sort of similar to like the first benchmark that we looked at. And then this one's very simple again. Again, these are sort of like based on like grouped operations, most of these. So there's the base R, like read.csv and aggregate. dplyr with read, actually using read R here for read underscore CSV. And then a group by and summarize. DuckDB using the SQL code rather than using duckplyr. And then making a note that you can just write this with duckplyr. And I'll skip right to the results. So these only had these three packages. Well, really just two packages. DuckDB doing quite a lot better than dplyr. So yeah, not really. I'm not like trying to advertise DuckDB. I was just interested in this package from some of these last RStat sessions and wanted to take a look more at these. So with that, I do want to I did some of my own testing that I think I want to show as well. It was a lot different. So it kind of surprised me when I tested it out on the cluster with like a real use case. So basically, I'll go through what I did. So I'll start with, let me make this slightly larger. Oh yeah, and by the way, I am using Positron now since like Gio's session last week. It works like I have a Mac. It's working pretty well. Had no issues setting it up, except one of the scripts needs to have execute permissions. Like that got me. I accidentally forgot to add execute permissions to one of the scripts, and it was really confusing at first. But after that, it worked pretty smoothly. So yeah, Positron's working quite well. Anyways, in terms of this benchmark, I mentioned this. This is a very similar use case to like the one I mentioned in the DuckDB RStats, where I had this really large CSV with clustering results. And I was trying to basically join it with the call data of a spatial experiment object. And I actually loaded it in here. So this is what the clustering results look like. There's a lot of NAs. And so this is here at the bottom. So the interesting thing about these clustering results is that you have it's in a really long format. So the original was, it was actually 500 million rows. So pretty large. And the reason is that like every gene is listed for every single barcode and every sample. And then you have like, it's actually factor K1 that is the clustering results. So there's a lot of NAs here. There's a lot of missing values. So this is, yeah, but the task in general was to read this in. This is the dplyr version. So reading it in, and then, well, I'm also using read, like, I think I guess this is sort of like a tidyverse version rather than just pure dplyr. But we have to duplicate the values. Basically, we only care about unique sample ID and barcode, since there's a bunch of genes, but we only care about the clustering results. We want to filter NAs because we only care about the clustering results that are not null, and then we're just renaming column. And then for the spatial experiment object, in practice, we would have the whole spatial experiment object loaded. For this benchmark, I just wanted to like load the call data to sort of isolate aspects that were like related to sort of dplyr versus duckplyr rather than spatial experiment related stuff. So I load in the call data and then I join it with the clustering results. And so this is the pure dplyr version. Some variations I did were, I was also curious about like, well, what if you just use, one of the things I had been doing for a while is I was just using like pure dplyr with fread from data.table, like not using data.table, the rest of data.table, but just for loading, fread is quite fast. So I was curious, like, what if we just use dplyr, but then replace reading with fread and then not really worry about anything else? So this was another variation. So really the only difference in this entire script is just this fread here, instead of read underscore TSV. Okay, so then the other versions I did a pure duckplyr version. I figured out some stuff when I was setting up duckplyr in the cluster. You do have to sort of explicitly set some settings. It's not really smart with identifying the resources from the actual SLURM request. So it tries to use the available resources on the entire node, which is bad. So you have to both set the threads to the number of core. Well, you don't have to do this, but I think it's recommended to set the threads to the number of cores that in the actual SLURM request, not the node. And then the memory limit, they recommend like 80% of the available resources. So this is like 80% of the request in this case. So this is some setup I do at the top. And I guess if you're using duckplyr, I would recommend using this in general. And this is on I have this linked on the RStat sheet for the actual code in case you need to reference this. I like doing this config setting where you set like, it's called fallback info. So that just tells you like when, like I mentioned, like last time when we talked about duckplyr, if it can't do some operation through DuckDB, it'll say like, I can't do this, I'm using dplyr right now. So I like that to be explicit. And so that's like the configuration type stuff here. Other than that, it's still like the dplyr verbs, using duckplyr's read CSV function, and then a collect at the end, which is saying like, instead of doing this stuff lazily, actually give me the result, because that's what you want at the end of the day. So, and then the final variation is duckplyr, but then with fread instead of the DuckDB thing. So yeah, those are the 4 variations. So the results were like kind of weird, and I'm still trying to figure these out. So I'll start with the memory usage. Make this a little bigger. So this was quite counterintuitive to me. One thing I was looking at is that, so on the left is the actual RAM use, the physical RAM usage. On the right is the virtual memory usage. And so we have like all the variations that I described. So weirdly enough, like I guess dplyr with fread was doing the best in terms of memory usage. One thing that was weird is that the actual physical RAM usage was sort of, I'm not sure I trust what SLURM reports for that. I was using other tools, and the requested memory, or sorry, the physical RAM used for like duckplyr was a lot lower when I used other tools to check it than dplyr. So kind of strange results here. Not sure what to make of it.
That might be a JSPC thing, right? Or
yeah.
SLURM.
Yeah.
But like the problem is that SLURM is using that actual information for deciding whether to kill the job.
Exactly. Yeah.
So it doesn't matter whether it's incorrect or not.
Yeah.
It's the actual thing that's being used to, to survey the correct usage of the cluster.
Exactly. That's why I reported it this way, because I did in the actual logs, like I did report, I was using like the time utility. I think it's a Linux utility. And like this one, just for example, was like 15 gigs of like physical RAM. So this was like, it was consistent across these. So about 16 for this was dplyr fread. So if we go back to that, dplyr fread for one core. Okay, so yeah, a little bit different. I was saying 16.
Kind of matches more closely the one on the right.
Yeah. Yeah.
That's like what, like 13%?
Probably. So yeah, I think I was getting a lot more consistent results from the other tool, but like Leo said, like if this is what SLURM uses to kill the jobs, that's what's important ultimately. So even if we're getting sort of weird values here. So this was memory, and then other interesting thing is time. Let me fit this. This was also really weird because there's some things that were expected. Like for example, the ones that use duckplyr benefited from using multiple cores. So that's expected. So duckplyr like is multi-threaded, and we explicitly used multiple threads when there were more cores. The weird thing is, first of all, like duckplyr and dplyr were like the same. The pure options were like pretty much the same in terms of time. So I'm not sure what is going on here. Maybe oh yeah, then I guess the third weird thing is that like adding fread to duckplyr was like the worst of all of them, which I kind of expected it to be maybe either the best or like the second best or something. So, and then what was expected is dplyr didn't really use, like as you added more cores, it's not going to really benefit. There's just sort of just noise, I think, the blue and the red. So that's expected. But what I guess if we go back to like the actual operations I was doing, let's go to like the pure duckplyr one. What I was expecting is that this read CSV would be faster and lower memory than dplyr, at least. I was expecting this distinct verb to be able to parallelize as well as the left join. So I was expecting that to benefit a lot from both the multiple cores and just in general be faster in DuckDB. So it's kind of weird that I'm getting like all the public benchmarks we went through had like duckplyr or DuckDB going like much faster than dplyr. So this was a little weird to see actually testing it. So some stuff to figure out in terms of like the cluster implementation. But I'm probably going to experiment with this a little bit more to see if there's anything settings wise that, or maybe it might just be like the dplyr verbs. Like if we just do like a group by here, if that, I think I'll test that out to see if it's like really the grouped operations that are well optimized in duckplyr/DuckDB. Other things I'll just quickly mention, this is sort of like a complicated thing, but like I was testing what happened if you use like different temporary directory space here. So if you set you might be familiar with like on the compute nodes, there's like this MyScratch. This is badly formatted, but there's a MyScratch environment variable where there's this 1 terabyte scratch space at JHPC. And so that's where the admins recommend like you set temporary space to. By default, it'll go on to like this /temp, which is on node specific. And actually it's a little faster, but I think they say it's like kind of unstable in a cluster setting for multiple people to be using that shared space at the same time. The time goes way up if you set for both the data table and the duckplyr. Actually, I think it went up for everything when you use the MyScratch temp space instead of /temp. But I was getting a lot of issues with running this benchmark I had to run these one job at a time. Otherwise, I would get issues with the /temp space, I think either filling up or something like that. So I don't know. Those are just like weird little details to note things I sort of figured out as I was doing this benchmark. So the scratch space matters a lot for performance, I guess is what I'm trying to say. But yeah, more to test with the grouping. and stuff to see if the reason I did this test is that this was like my first real use case for this, where I had hundreds of millions of rows and I was trying to do this. And originally it took like 9 hours to do what I was trying to do. So I was trying to really get this down, but looks like this particular use case didn't benefit much from DuckDB. So I guess it's really highly dependent on what you're doing is maybe the takeaway message, but it's really not going to be doing worse than dplyr at any point. So, and it's pretty easy to use. So I'm going to be using it probably more often, but yeah, that's all I had for today. Hopefully these benchmarks were interesting. And I think I still think I'm going to be using duckplyr a lot.